All right, so I heard 3, 4, and 5. We'll plow through these and then jump into the new stuff, which will actually be the last bit of new things that we are going to learn in the math portion of this class. So number 3.
Then we gotta read, right?
Yep.
Bruh.
And you gotta what? Can we stay doing math?
Read.
Let's say doing math. I
You.
don't do math.
I do math over reading any day.
No. It's a good try, though.
Can I do like 15 pages math, but only instead of reading 5 pages?
No. So you hopefully figured out u should be equal to x minus 1. Any questions on why that is? X minus 1 is the inside of that function. So we have to do the derivative then. Derivative of u with respect to x is just going to be equal to 1. And so that means when we're solving for dx, dx is going to be equal to du. Yeah. So now we just rewrite the thing. And this is where it gets a little bit tricky. So our goal is to get rid of these x's and make them into the letter u. But we can't just erase and do that. We actually have to do math to make it legitimate. And so we did that with this. This is going to be equal to the square root of u. That's nice. But under particular circumstances, like this one, if we've got this x that's still hanging out there, it totally ruins all our fun. So in order to get rid of this x, all you have to do is go here and figure out what x is equal to. So if u is equal to x minus 1, that means that x is equal to u plus 1. So we're going to replace that x with this. And du. And now we can go ahead and hopefully try and solve this thing. So this is u to the 1/2. So 1 to 2, u plus 1, u to the 1/2 du. And what I want to do is I want to distribute this through so I just have the letter u in here. Because you can't really take integrals of these separately. So it's best to just take this and get 2 separate u functions. So u to the 1/2 times u to the first is going to be 1 plus 1/2, so 3/2. U to the 3/2. U to the 1/2 times 1 is u to the 1/2 du. With me so far? All right. So then the next step is to actually take that integral. So in order to do that, we add 1 to the exponent of both. So 3/2 becomes 5/2. And the inverse comes out in front. So that's 2/5 u to the 5/2. Plus this becomes 3/2, because 1/2 plus 2/2 is 3/2. U to the 3/2, the inverse comes out in front. And that's all going to be evaluated from 1 to 2. And now the next step is to put back our u value in for this.
Hey Ben, can we use your tag pen?
You know Mrs. Neighbor has one too?
Should I? Thank you.
X minus
Because you need one.
How are you doing?
Go back up.
Wish we got to do perfect then.
Whoa. Okay.
All right.
Here we go. Back to some math.
Actually, gonna need some too.
So that's where we end with this here. Evaluated from 1 to 2. So you would plug in 2 for this, 2 for this, put that in a giant bracket, and then you would subtract, and you'd put the 1 in. And when you do all that, you should end up with 1.07. Questions on number 3? Was this 3? Yes.
How did you go from, like, the third line to the fourth line? So, like,
This third line or
the one above that to the
this
bottom.
one? From here to here?
Yeah.
I multiplied this u to the 1/2 by 1, and I multiplied the u to the 1/2 by u to the 1.
Okay.
So that's number 3. I'm sure number 4 will be easier, right?
No.
Well, we'll find out.
Depends what the answer is, because that could be really close, that could be
I
really
thought
far.
through it now, I don't know. Could give it another shot. But who likes watermelons and natural water? Nobody.
Did you say who likes water balloons and natural log functions?
Log
I mean, pretty
balloons and
close.
natural logs.
Water balloon and that.
Do it. Ben, I got 100% on the calculator today. You'd be proud of me.
Good job.
What'd you get?
Nice,
Wait,
Jaden.
wait, time out. Did you get 110 or what'd you get?
We got 100. You can't get extra credit than us.
Disappointed in you.
Oh no.
What do you get on the test?
I expected more. Yeah, like an 86.
I don't remember.
I think
But like,
I got 100.
I didn't get 100. I got 99.
All right, what should we set u equal to?
Better than you.
It's not true.
X. Radical.
Square root of
Square root of x.
Yeah, I'm getting it.
That's what we should do. So
how are you
Oh,
like?
I'm wrong already.
one of the ways you can figure that is, inner
No, you
function.
see, we're not allowed to use square root. What? I'm confused. Because you wrote something on the board the other day. It says we have to put 1 for x for some sort of stuff.
Yeah, because
Me just sitting here not getting it right either way.
you
I don't
take
remember.
the derivative of the square root of x, you get.
Because you said when if we take square root x out of the function, it will turn back on, will be the same thing.
Well, yeah, if you set u equal to x, you can set it equal to square root of x, though.
How do you make
I don't
that
know what they're
change?
talking about, so.
I was doing so good in like.
I'm sure I said something funky yesterday.
Why can't you do that?
Like, I was confused. Like,
So, yeah, if we would set this equal to just x, it's not going to get us anywhere because we're just exchanging letters. But if there's no inner function like this, what we do is if there's an e, we usually set the u equal to whatever that exponent is, in this case square root of x. Which is the same thing as x to the 1 over 2. So, alright, what next? du by dx. So derivative of this is going to be 1/2 x to the negative 1/2. And that means that dx is going to be equal to 2.
no, wait, why is 1/2 x over negative 1/2?
It was minus x.
For the derivative, we pull this out in front, and then we have we subtract 1 from the exponent.
Oh, yeah, never mind.
that not yours? Yeah, I didn't. I could take it and you give it back.
Is everyone okay?
Sorry.
No problem. Okay.
Bye, Josh.
Bye, guys. Bye.
So now we're at this point. Let's make sure I don't get confused here. So I'm going to flip these. So that'll be 2. And then this is going to be x to the positive 1/2, right?
Yep.
So 2x to the 1/2. Yeah. So dx equals 2x to the 1/2. Now we can put stuff back in. Integral of 1 to 4. We got e to the u over u times 2x to the 1/2. du, yep.
Why did it become positive? The negative one.
This is a fraction.
Doing the reciprocal, so the reciprocal is 1/2 is 2.
This makes so much sense now.
And then the reciprocal.
Now it makes more sense. Now
So
I
like
understand.
if you thought of x.
Oh.
I don't know.
So we take
So-
the reciprocal of exponents too?
Okay. So here's the thing. If you got mixed up in this one, it's totally understandable. I would have been stuck for a couple minutes at this point too, because this x has to be gone, otherwise we're screwed.
And it becomes u.
So, in order to go anywhere from here,
Oh boy, we have to do.
No, it
it's
is
x
u.
to the
You
half
have to do
of
the
the
quadratic
square root of
formula.
x.
It is
So you
u.
just replace it with u.
yep, so this x becomes the letter u.
And then you can just get rid of 2 u's.
Yeah.
These last 3 days have been brought to you by the letter u.
Mr.
That's
Hadley,
just 2
yeah, on the
u
test and
to
quiz, how difficult of this problem gonna be? It's gonna be like, as hard as.
Not this hard.
Okay, so we're.
Yeah, this is
More like 1
yeah.
and 2?
You do need to know the little trick where you have to put like the u plus 1 from number 3. So be aware of that, but
That's not that bad.
no.
Yeah, that's not it.
So this one, next step is to,
Cancel u.
yep. So you go away,
Very good.
u to u.
and the 2 can come out in front. Now we're getting somewhere, all right.
Yeah.
Actually, this one gets easy.
Yeah.
Nothing happens.
So integral of this is equal to that. So the,
2e to the u.
yeah, 2e to the u evaluated from 1 to 4. So 2e to the 4 minus 2e is equal to something, and that should be 9.34. There's a lot of little tricky things in here, aren't there? That would have held me up for a while if I didn't have my little answer key here.
How about if someone told you that you're supposed to set u equal to e to the square root of x?
Just set u equal to e to the square root x over square root x. How about that?
There you go.
I was looking at that and sitting there, I'm like, what? I was about to take the.
But I was
log,
confused
the
as you do.
Natural log of square root
I
of
just
x.
did it this
No.
morning for him to help.
I thought
me,
u
so-
was x, and I
Oh.
thought I was solving it pretty good, and I got negative 0.82. But it made sense in my head.
Yeah.
Well, since
It's
when
just
is
lower
Lawrence
than
Rivers?
Rivers.
You can put the
Oh,
math in.
sorry.
It's
Alright.
really weird.
I haven't seen you without the mask.
Okay.
And I got the answer key up here too if you need it. All right, we got one more, and then we've got some new material.
I got
When's the test again?
Wednesday.
Yeah, I think.
Today is Wednesday.
I'm totally relying on
Back
you.
at Thursday or Friday.
Was it Wednesday?
Yep.
Okay. Whatever it says on Schoology. Okay.
So we already passed the test?
Done.
I have
It's
no
right
doubt that you will all pass the
You forgot to give us a test yesterday.
No,
Does that mean
this
we just
is
move on
the
to the next
test.
one?
I think we're doing
Hey,
okay.
I got the first 2 right, that's all that matters.
I got like everything except.
Oh my gosh.
Yeah, it's Wednesday.
Oh, it's next Wednesday. Oh.
Yeah.
All
Today
right.
is Wednesday. It's
Well,
right
there's
now.
that.
Alright.
So u should
you're
be
so
equal
smart.
to 1 plus 2x because it's the only inner function we've got here.
Dun, 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 dun,
So du by dx is going to be equal to 2. So that means,
22x and 1/2.
okay, so we're all right so far. 0 to 13. dx is by itself, so it's going to be 1 over, all right, the cubed root of the square. So that's going to be, can we just like make this into one thing right away here?
Yes.
So, yeah, right, because this would be u to the negative 2/3, right?
Yep.
So then, yeah, putting it back up there, u to the negative 2/3, okay.
There's no square root.
Right,
It's u to the negative. Yeah.
there we go.
2d.
1/2 d. So, 1/2 is going to come out in front. U to the negative 2/3. Oh, gosh.
Yeah, it's a lot.
Maybe I should do decimals for this. U to the negative 0.66666.
Yes.
Yeah. Yeah.
See, that's why fractions are better.
Nah.
You lost me there.
All right. So from this, we got to add 1 to the exponent. So negative 2/3 plus 3/3 is 1/3, right?
Huh?
Yeah.
Okay. Evaluated 0 to
I
13.
seriously think it's the simplest steps that I messed up on. Like just adding one, I'm like,
You
wait,
see, I messed up
what?
on the simple stuff, but that's okay, I also messed up on the hard ones.
So then the next step, we got to plug our u value back in. Yeah.
For the integral of. Might have helped.
Yeah.
That's okay.
Okay, wait.
So, yeah.
The whatever, yeah. Wait,
Is there supposed to be a 3 something?
yeah, it's.
Did I miss
you
a
didn't-
three?
Move the
you didn't
three
move
out.
the 3 out. You have to take the.
Because that's the
Inverse of the-
derivative of.
Oh,
1/3.
yeah, yeah.
It's 3.
Yep.
It's just 3 over 2.
So 3 halves.
So 1/2.
There you go. 1/2 times 3, so we got 3 halves there. And then there's this 0 to 13. So then you would plug in 13 here, and then from that you would subtract, and then you would plug in 0 there, and you would get a number. In the end, that number should end up being 3.
Yeah. No.
Almost, but no.
Wait, this time I had a whole number in, but that was almost good.
I knew that was.
This is why I can only do one question at a time. Too much it takes out.
Okay, I'm wondering, did we forget to do this in the last one?
Maybe.
I don't remember plugging the regular value back in for you. I'd have to look again.
We didn't do
We didn't
but
do that?
We did the answer.
Okay. So yeah, on the last one, you would have to make sure you do this step before you get your answer there. Okay, any last words before we hand in worksheet 8?
We're not going to talk about
Any
anything,
last
just
words?
new work.
Well, yeah, we got some notes which we'll be taking. This is the last round of notes for calculus-based stuff.
Do what you want.
And it is, well, I'm not a big fan of it. But it's the sort of thing that we have to do because occasionally they put stuff like this on the AP test. And the way they handle this particular type of math problem, I'm still kind of wondering why they do it the way they do. You'll see as we go. If you're good to go, I will come around and grab that worksheet.
It was kind of weird.
How's our buddy October Wednesday?
Oh, he's doing great. He was helping me do the dishes the other day.
Oh, we'd love to see that.
Sure. I'll bring her on. Yeah. Sure. I'll get you a pass set. Thank you.
What are
Do you have like a little, can you
doing?
walk?
I'm like so tired. I didn't stay up.
We're only up till Thursday.
Yeah, I was only.
Looked at us. I don't know how I would survive if this class is anything other than the last hour, because my brain is like fried after.
Anyone go to Macy's?
Just finish filling this out for me now. September 16th, and it's 3 o'clock.
I don't like it.
Dude.
So, Mr. Hathaway, do you go to Macy's?
Laser. Oh
Uh,
my god.
not really. I don't really shop for clothes because I haven't grown in forever.
I feel that
You
one.
can still go to Macy's just because. Like,
Whoa!
That's okay. That's why we practice math.
You literally lean forward, so I can do it.
Yes, that's what happened when I
I'm allowed
tried to do
to.
dishes the other day.
That's gonna look really weird on the black.
Tried to do the dishes.
I mean, at least you don't have to do all that.
True.
Whoa.
My
Whoa.
leg.
Thank you.
We don't need that.
Aw.
Did you see that?
Okay, it makes your head.
Huh?
It makes your head.
I guess it's just because of the shutting down.
He's
He's in
What
the-
was
one too from senior retreat, so it's even better. Like,
Even the dishwasher, right?
Baby dash.
Yeah, yeah.
makes it harder to notice. You think it's just the cat.
Yeah,
How long
I'm
from
sure
like
no one
halfway
noticed
to
the
bathroom
seven
or
you
something?
were around.
Who's smarter, you or your brother?
Me.
Which brother?
Isaac.
Me
I didn't know there wasn't another brother.
Jacob.
Isaac.
and Josh. I have 4 siblings.
Jake and Josh?
The little one, right?
Not Jake.
I don't know. Isaac's pretty
Jacob.
smart.
Jacob?
Yep, go.
Isaac uses big words in his vocabulary.
He uses big words to seem smart some days.
So he's
Compensating.
Jake and Josh?
No, Jacob.
These are my
and
world
Josh.
class. Pretty smart.
Jacob.
All right. So the words I'm about to write on the whiteboard,
Are
Don't
not
I have
as-
a bad history with. I hated differential equations in college.
Differential equations.
So you're not going to teach it to us because you know what it is.
No, he
Please
has
don't,
to.
please don't.
He doesn't want to.
Those are
And he's
Joe
teaching us.
So why is that PCR over here then?
This was the toughest part of Calc 2 for me by a long shot. And of course, because I hated it so much, they required us physics people to actually take a course called Differential Equations later. So, it was wonderful, and I hated it. I don't even know what my grade was, but it sure wasn't an A, and it sure wasn't a B. So,
Sure, it's an A+.
A+.
yeah.
You're
One
really
thing I-
salty towards this, aren't you?
Oh my gosh. I'll tell you what, after I graduated, Swart Hall was the building that all the math classes were in. Every so often, I would go in that building after I graduated and just walk down the halls and be like, I feel so bad for you people looking in the classrooms. But it was a good feeling that I was
I
finished.
got out.
Oh,
I really thought that was somewhere else.
I thought you were going to
Yeah.
like spit on it.
no.
That's right. I don't know. That's what I expected.
I try not to be too bitter.
Wait, you
But-
have a weird history with fire.
Yes,
that
I
could have been
do.
where it started. Or where it was going. I'm tired. You know.
That's okay.
Same thing.
All right. So, differential equations. The way that you would be taught this in a math class is different than the way I'm going to teach it because in the math class version, it doesn't really apply too well to how they use it on the AP test in the springtime. So I tailor-made this just for those particular problems. So oftentimes they'll say like, they'll give you an equation, they'll say solve for this as a function of time. For instance, F equals MA. Solve for velocity as a function of time. So, what the heck?
I don't know.
Because there's no velocity in that equation, and there's no time in that equation.
There's acceleration.
There is. And so what is acceleration by definition?
V over T.
Yeah. Change d, in other words,
So you gotta memorize a bunch of stuff too? Like
acceleration is change in velocity over change in time. And another way to write that,
V1 minus V0.
Oh, no.
We're taking derivatives?
kinda.
It's
So, acceleration is nothing more than the derivative of velocity. And velocity is nothing more than the integral of acceleration. This is how this all starts to tie into physics. If you have a position time graph and you take its derivative, you get its velocity time graph. And if you take its derivative, you get acceleration.
Oh,
If-
did we talk about this last year?
Yeah, just briefly. If you start with acceleration and you take its derivative integral, then you get velocity. If you take that integral, you get position. So you can go between all those things. So here's the thing. If we want to get velocity and we want to get time, what we got to do is rewrite this equation to this. And then what we have to do is we have to separate the dv and the dt. Why? Because that's just how we roll. So the next question is, which goes on which side? Like, does the t go with the m or does the t go with the f? The only thing I can tell you with this, because they never really point out exactly why they divide it up this way on the answer key on the AP test, they always move the t to be on the same side as the m and the v to be on the same side as the f. So if I want to do that, I'm going to have to do, I'll show an extra step here. So it's like we take this dt and then maybe move the dt over there. And then we got to move this m over here too. So then that would be m, rather
DTM.
No, that
Over
that'd
M.
be dt over m.
1 over m dt
It is real.
is equal to,
dv over f.
yeah. I don't know why they don't just leave them, like put dt over here and call it a night. But that's just, this is how they solve it every single time. And they never explain why, but it is what it is. So, in order to actually get anywhere with this, we got to take integrals. So, the next step, I suppose I should say before I do the next thing, any questions on how we got from here to here?
Can you say dt over m and dv over f?
That's fine too. The next step is to integrate. Now this is actually not too bad, this part, because this is with respect to t. There's no t in here to integrate with respect to. So what that means is like a constant comes out. So if you're taking the integral of 4 with respect to x, the answer would be 4x. So if we're taking the integral of 1 over m with respect to t and there's no t, the answer is t over m, or 1 over m times t. Same thing over here, there's no v, so the answer is v over f. So if you want to solve for velocity as a function of time, you just get the v by itself. And that's your answer.
Hold on.
Is everyone okay? Are we
Space
still
time
here?
over mass.
Force time over mass equals velocity. Yes.
There we go.
Hold on.
I get
Thank you.
As you finish writing that, I'm going to get the next one started.
Oh boy.
Force time over mass equals velocity.
This thing made me want to sleep.
Yeah.
completely irrelevant, but is chemistry required to graduate?
No.
Okay.
It's better not, I didn't graduate after taking chemistry. I stayed away from that class as far as I could. It's like I had a hard enough time in physical science with the chemistry stuff.
Chemistry's easy, people.
Well, not for everybody. I am not a chemistry-minded person.
Why was chemistry hard?
Oh wait, are you recording?
Yep.
Hi Sarah. You're watching.
She's missed like 4
Hi,
days in a row
Sarah.
now.
No.
I don't think she'll be able
Oh,
to
it
catch
was
up.
like 2, 3, 8, 12, I don't know.
She's been here since last Friday.
I don't know, no one was here Monday, and it's only the second day of the week.
Yeah.
You know what I'm
All
saying?
right. One of the other things that they can throw into this as a bit of a wrinkle is they can say, yeah, solve it for velocity as a function of time, but we want you to write it in terms of this, please. So if they specifically say that they want you to list it in that type of form, it's the same procedure, you just change some minor things at the end.
You just say VOT.
That's,
and-
F time minus F velocity.
Oh wait, no. Force of tension minus force of friction.
Yeah, tension minus friction
Oh.
equals MA, something from our force days.
So you guys, I remember.
So what we would do here is we would deal with this the exact same way we dealt with the last one. Tension minus friction equals MA, but A is really dV over dt. And then we gotta separate those. The T and the M gotta go together, and the V and the forces gotta go together, just because that's what we have to do. If I had to guess, maybe I'd say that the velocity and the forces are connected, because if you change your force, it's gonna change the velocity, but I can't say for sure. So it'll look about the same as the last one.
Now you gotta integrate.
You got it.
Okay, Gruber.
Now, if they tell you to do it with v of t, that means you have to start putting limits on your integral. So with time, your limits are always going to be from 0 to whatever the t is for time. For this, it's going to be 0 to velocity with respect to time. You're going to get pretty much the same answer though, because these zeros are just going to make it 0.
Okay, those zeros make it fine.
No, because it's going to go in the numerator for the other one, because they go in where the t would be.
Okay.
This will be t over m, and this will be v t minus force of friction. So then, evaluated from zero to t, evaluated from 0 to v of t. When you plug the zeros in, they're both going to, just be nothing because they're going in the numerator. That'll disappear. So you'll end up with t over m on the left. And you'll end up with that on the right. So in order to solve for v of t, you just got to multiply both sides by the difference between those two forces. And that would be where you land. Man, I hate this stuff.
No, all of them do make sense, and then you kind of lost me in the red.
So when we go from, well, let me hand out the homework first. There's just 2 problems. Just try your best with this. I don't want you to see the answers before tomorrow. I'd like to see where you go with it. But yeah, I'll run through that again before we conclude here. Do I have 30 seconds or do I have a minute? 30. 30.
You got 30 seconds.
Yeah.
Could you just say it in front of the camera and I'll watch it like
Oh, we got Patrick here. So
Yeah, sure.
Thank you.
No one told me you guys did nothing yesterday. Yesterday?
See what you can do with this. No worries if you get stuck, that's
Okay,
okay.
good, right?
So just real quick, when we go from blue to red here, we're doing the integral. There is no t here, so a t appears, and it goes in the numerator, because it's like going 1 over m times t. Over here, there's no v, so the v appears, multiplied by v, so it goes in the
Just one
numerator.
announcement this afternoon.
Oh,
All
like doing-
NHS members, remember there is a voters meeting tomorrow during resource in the upper gym. Officer essays will be